Today I would like to give you a fantastic talk about better stents and new wrinkle. Does anyone in your family have heart disease? In 2010, it was reported that 1 out of 3 American adults have some form of heart disease. The most common form is atherosclerosis. Fat or plaque is built up in your blood vessels, blocking blood flow from your heart to other areas in your body. Imagine in your house, the pipelight start have problem. A lot of fat or grease from cooking has built up in your pipelight. Your pipe in the house could clear out really easily using drain cleaner, but it's not so easy for blood vessels. To open or enlarge the narrow blood vessels and restore blood flow, a stent, a small mesh tube, is commonly used. Doctor will thread a thin, flexible tube with a deflated balloon at its tips into an afflicted patient's blood vessels. A stent is placed around the balloon. As the balloon inflated, the stent is unfolded and push the plaque against the plaque vessel wall and restore the blood flow. Therefore, 1 in 2 treated patients need another stent replacement every other year. To defend against unknown implants, our body responds to the implants. Defending cells wrap around the stents. Over time, the plaque is reformed. Macrophages or white blood cells is one of the frontier defense soldiers attacking the implants. So the question is, can we make a better stent, or can we prevent the side effect of the stent placement? Up to now, many studies have shown that cells' behavior can be altered by 2 things in their surrounding environment. The first is something we call soluble factors. These are substances that can be easily dissolved in water, like sugar or salt. The second involves in physical factors, what are in the solid form. These are factors that may denote a material themselves, such as plastics or steel, but also architectural characteristics like being flat or curved. While many studies have understood about soluble factors, but very little understood how the physical factors can change the cell's behavior. For a long time, cells, although mobile, but do not drastically change their shape in order to accomplish their task. However, in our study on macrophages, white blood cells, we found something really surprising. We found that cells change shape. In response to the surfaces they live on, cells could be changed from round to long. The change in cell shape led into the change in cell behavior. So in this study, we proposed to change the architectural feature of the stents that led into the change in cells shape around them. To do that, we study how cells respond into the groove surfaces that can be suggested as the architectural feature of the stents. We fabricate these groove surfaces with very simple methods. Using heat, we shrunk a very thin film plastic with confined at 2 ends by clips. The result, we found that the wrinkle indeed causing the cells get longer in shape, and then they become less sticky and less attacking these wrinkle surfaces. We also found this cell's behavior not only in cells study but also in animal study. We implanted this material underneath of the mouse skins for 7 days and studied how the mouse body responds to the wrinkle implants. We found that the cells around the wrinkles materials has less active and attacking the wrinkle surfaces compared to the unwrinkled materials. Change in cell shape led into change in cell behavior. It's similar to how the frame of shape changing the behavior of growth of the tree. Have you ever seen that the tree growing into the chair shape? It's amazing! Changing the texture of the stents material by simply adding our wrinkles make better stents. So in the future, we plan to apply these wrinkle surfaces onto a real stents so we can extending the time of stent replacement. In 20 years, with the new designs using our wrinkles, patient might need only one time to place a stent. So the question is, can we prevent the side effect of stent placement? Can we make better stents?